Okay, now we want to move on to looking at what we call calculus in the physical world. So the actual calculus that we do apply it to physical situations. The first one we want to look at is rates of change. Now we've looked at a rate as before as changing of a quantity with respect to time. So what we've got to notice mainly is that our rate is going to be of some quantity, but it's changing with respect to time. We still want to keep the idea that rate is the first derivative. So we want to keep that in mind as we keep going. So qt is the function, dq dt is the rate of change. So if we look at this in a question here, a trench being dug by labourers to remove v cubic metres, and there's the expression for the volume. We talk about the rate of the soil being removed at the end of 40 minutes. That means the first derivative. So derive 10t becomes 10 t squared over 20, 2t over 20, or t over 10. And at 40 minutes, well, what rate is it being removed at? Substitute the 40 in. It means that taking the soil's being removed at 6 meters cubed per minute. So there's the rate per minute after 40 minutes. Are the labours working at a constant rate? Well, let's have a look. As t approaches infinity, the v to t approaches 0. So no, we can say that it keeps decreasing. So the rate of work that they've got is decreasing all the time. What's their initial rate of work? Now we've got to pick out pieces of language. Initial means t is equal to 0. So when we're doing calculus in the physical world, initial t is equal to 0. We've got to use that. So sub it in. T is equal to 0. Just gives us 10 meters cubed per minute. And D, at what time are they removing soil at a rate of 5 meters cubed per minute? And so V to T must be 5. 5 is equal to 10 minus T over 10. T over 10 would be equal to 5. So after 50 minutes, they're removing soil at a rate of 5 meters cubed per minute. So rate is the first derivative, and we've got to keep picking up on all language.